Welcome to qnawire.
Okay, in this problem we have a particle in a box in one dimension. We are asked to take a look at the probability density, P of x, and in particular, which x values result in a minimum value of P of x and which x values result in a maximum P of x. And we're asked to just look at the ground state, which is the n equals 1 state. So the only thing we need to know for this particular problem is that the wave function for an infinite square well in 1D is given by a sine of n pi x over L, where L is the width of our square well, and are the energy levels, x is the location, of course. And A is some normalization constant, which we don't actually need to worry about for this problem. So the other thing we need to know is that the probability density function is simply the complex square of the wave function. In this case, there's no complex valued anything we need to worry about, so it ends up just being the square. So psi squared. So let's actually compute that. We would end up with a squared sine squared of the same stuff. So our probability density is given by a sine squared constrained for x between 0 and L. So let's take a look at what this would look like. So for the n equals 1 case, our probability density is a squared sine of pi x over L going from 0 to L. So if we plotted this, this ground state would look something like this. L, 0. And right in the middle, this is our L over 2. So remember, if x is equal to L over 2, we have sine of pi over 2. And if we just look at a normal sine function, not that I really need to refresh your memory on this, 2 pi over 2. So when x is L over 2, it results in a sine of pi over 2, which would give us a maximum, which is why we have a maximum P of x. When x is equal to L, we have sine of pi is 0. And of course, sine of 0 is 0. So we have max probability when x is equal to L over 2. We have minimum probability right at the edges. So when x is either 0 or L. And this is consistent with the figure that they show you with the different energy levels. And you notice that as the energy levels go up, you get more and more peaks in your sine. So for example, the first energy level would look something like that squared, and next one would be 3, and so on, going up in n. And that's it. Very simple analysis.